In section 8.2, we're going to be looking at a new family of functions called the reciprocal function family. So functions that model inverse variation have the form f of x equals a over x, where x cannot be 0 because as we know, that would be undefined. These functions belong to a family whose parent function is the reciprocal function, which we talked about yesterday, which is f of x equals 1 over x. The general form for this equation is y equals a over x minus h plus k, where x cannot be h because, again, we don't want that denominator to be 0. Also, what we talked about in 8.1, this is what the general form of y equals 1 over x would look like. So just to start off here, let's just talk about graphing these kinds of functions, how we could go about that, identifying intercepts, asymptotes, and stating the domain and range. So in this first example, I want to figure out the graph or sketch the graph of y equals 8 over x. Then I'll just kind of move on from there. So y equals 8 over x. I would just plug this into my calculator and find coordinates here. So going through that, I see I have negative 16, 1/2, negative 1/2. Plot my next coordinate, I got negative 8, negative 4, negative 4, negative 2, negative 2, negative 4, negative 1, negative 8, and negative 1/2, negative 16. So I kind of have a curved line down here, and then what you'll notice is that I kind of have the symmetrical part in the opposite quadrant. So in quadrant 1, I have just the opposite coordinates here. So I have 1/2, comma 16, 1, 8, 2, 4, 4, 2, 8, 1, and 16, 1/2. So this is what my graph would look like. And then once I have a couple coordinates on each, I can just kind of like make my curve. For the x and y intercepts, that's when I'm crossing the x or y axis. My x value can never be 0 in this equation, so there's no y-intercept. So that function is never going to cross the y-axis. So there's no y-intercept. Similarly, the numerator of y equals a over x, or 8 over x, is never going to be 0. So there's also not going to be an x-intercept. These graphs, or this function, never is going to cross the x-axis either. So the y-axis I would consider an asymptote because I'm never going to cross it. And the x-axis is also an asymptote of this function. Finally, for my domain and range, my domain here could be all real numbers other than x equals 0. And same thing with my range. My range here could be all real numbers except for y equals 0. So let's talk about what each part of this general form of the reciprocal function can do. So again, the parent function is y equals 1 over x. If I have any stretch or shrink on that graph, that's going to be with that a value, okay? So y equals a over x would represent some kind of shrink or stretch, and a reflection would be if that number was negative, and I would reflect that over the x-axis. Finally, this is the important one. If I have any kind of translations vertically or horizontally, that would happen with that h and k coordinate, similar to when we saw in absolute value equations and quadratic equations. What's important here is that this graph will tell me any vertical and horizontal asymptotes that I have. Any vertical asymptote will be the line x equals h, so whatever that number that you see there in the denominator, but with the sign being opposite. And any horizontal asymptote would be any k value that you see. So finally, when all of this is combined to include shrink, or like any kind of stretch or shrink, along with any kind of translation, I get that general form y equals a over x minus h plus k. So let's end this with two examples using some translation and stretch there. So I want to graph the function y equals 1 over x plus 1 minus 2, and I want to state the domain and range. So looking at this without even using my graphing calculator, I can look at that x plus 1. I know that that represents x minus h, so I know that that h value would be negative 1. So x equals negative 1 is my vertical asymptote, so I'll sketch that out there. I also see a negative 2 there telling me that y equals negative 2 is an asymptote. So I have my two asymptotes, and from here I can kind of just sketch my graphs. So here I found like two actual points, and then I just kind of drew my curves along those asymptotes. The domain here would be all real numbers except for x equals negative 1, because I'm never going to cross that line. And my range would be all real numbers except for y equals negative 2, because I'm never going to have a coordinate for y equals negative 2 either. The last graph that we'll look at today will be kind of working backwards. Here I have the graph of a function that's a translation of the graph y equals 2 over x. I want to write a function for this graph. So I see that I have a vertical asymptote at x equals negative 3, and a horizontal asymptote at y equals 4. My general form, I have y equals a over x minus h plus k. I was already given my a value in that function there, so my original function was 2 over x. That means my a value is 2. My h value is negative 3, so I'd plug in negative 3 for h. And my k value is 4, so I plug in 4 for k. Now to simplify everything, minus the negative turns positive. The function for this equation would be y equals 2 over x plus 3 plus 4, and I would be done.